You build these things, right? You spend time putting together an AI agent in n8n, hoping it's going to, automate something cool for you.
Yeah.
And then it just goes completely off the rails. It makes stuff up, or maybe it totally ignores the tools you gave it, and your whole workflow just breaks.
Yes.
That feeling, it's incredibly frustrating.
Oh, absolutely. Anyone who's tried to move AI from a cool demo to actual automation has hit that wall. And I think a big part of it is just how a lot of resources still teach you to build these things.
Right. It feels like the standard amateur way you see online is grab a basic model, write a super simple prompt, cross your fingers, and just hope for the best.
Pretty much.
And then you're surprised when it's not, reliable.
Exactly. And the source material we've got for this deep dive, it really cuts through all that. It's pretty blunt about it, saying if that's what you're doing, you're kind of building a toy, not a production system.
Ooh. Okay, so this deep dive then, this is like the antidote. It's about moving past the toy phase and actually building something that's robust, something you can depend on.
That's the mission. It's about pulling back the curtain on what the professionals really focus on. It's less about just prompt engineering, although that's still important, and way more about the configuration.
The configuration.
Yeah, the source highlights 7 key settings that, honestly, most people just seem to miss or maybe ignore.
7. Wow. Okay, so we're talking architectural design here, right?
Yeah.
Building predictable, reliable systems, not just, getting lucky with some clever wording in a prompt.
Precisely. This deep dive is all about understanding the engine control unit for your AI automation, not just the driver trying to steer.
Okay, I love that, the engine control unit. So, all right, let's unpack this. Where do we even start with this configuration mindset? Why does it matter so much?
Well, the source makes it really clear from the jump. Configuration is the foundation. It's the difference between something that's maybe a cheap internal tool that saves you an hour here and there and a mission-critical business system that you actually depend on.
Right.
Missing these settings means, as they put it, your brilliant prompt is like a brilliant driver in a car that's just fundamentally not configured right. It's never going to perform reliably.
Okay, so it's not like a minor tweak. It's the core of building something that's not just going to, I don't know, randomly decide it's a potato halfway through your process.
Right. It's about predictability and scale. And the source dives into these settings one by one, which is super helpful.
Okay, let's do it. First up, they talk about choosing the right AI brain.
Yeah.
And I got to confess, defaulting to the GPT-4 or the latest famous model for everything, that feels relatable. I think I've done that.
Yeah, and the source uses this great analogy. Using GPT-4 for every single task is like using a Formula One race car to deliver a pizza. I mean, it's incredibly powerful, sure, but it's also wildly expensive and, frankly, totally overkill for, a simple delivery job. It's the wrong tool.
Okay, yeah, that makes so much sense. So what's the professional framework for picking the right brain for the right job?
The source lays it out really clearly based on the task you're trying to accomplish. If you need what they call Einstein-level reasoning, complex problem-solving, strategic thinking, deep synthesis, you're looking at models like maybe DeepSeek V2 or some of OpenAI's newer o1 series models.
Okay.
A good use case there would be analyzing complex market trends to develop a strategic plan. But heads up, these really heavy thinkers, some of them might not support tools well, so you got to check the docs on that.
Okay, so for the really big, chewy problems, what about speed? Real-time interaction?
Speed is totally different. For light and fast responses, real-time chat, interactive apps, you need models optimized for pure speed.
Yeah.
Think Grok or maybe Gemini 2.5 Flash.
Gemini Flash, yeah.
That's your customer support chatbot on a website. It needs to feel instantaneous, right?
Got it. Speed demons for speed tasks. And what about bigger companies with, strict security needs, compliance and all that?
That's where you lean into enterprise-grade security and governance, models available via services like Azure OpenAI or AWS Bedrock.
Right, the cloud provider wrappers.
Exactly. If you're dealing with, say, IPA or GDPR compliance, or you just need to integrate deeply into a secure cloud environment, using these services provides the power of models like GPT-4, but within that necessary secure wrapper.
Like for HR data or something?
Yeah, an internal HR assistant dealing with sensitive employee data is a classic example.
Okay, what if privacy is paramount? Like the data absolutely cannot leave my servers.
Then you're going privacy first and self-hosted.
Yeah.
Models run locally using something like Llama, maybe running Llama 3 or Mistral locally, or using Mistral models directly gives you absolute data control, which is huge for some businesses.
Right, if you're dealing with super sensitive IP or financials.
Exactly. Processing, highly proprietary financial data on a local server, for instance.
What about seeing images or like reading charts, multimodal stuff?
Yep. For that multimodal magic, you need specific models. Google Gemini 2.5 Pro is known for strong vision capabilities, or maybe GPT 4.5 if you're in that ecosystem.
Okay.
Analyzing images of product damage from support tickets, seeing the photo and understanding the text description, that's a perfect use case there.
Okay, so we've got power, speed, security, privacy, vision. That's a whole lineup. But what about cost? Because honestly, those fancy models can get really expensive, right?
Massively. And that's where the cost-optimized production models become essential. Think GPT-4o Mini or other lightweight models.
Mini, yeah.
When the task is relatively simple, like basic classification, simple data extraction, or Q&A, and you need to process thousands or millions of requests affordably, these models are often, 90% as capable as their bigger siblings, but at a tiny fraction of the cost.
Okay, wow. So the real professional approach isn't just picking one favorite model, but like having a whole arsenal and choosing the absolute best one for each query on the fly.
Exactly. And that's the dynamic model selection they talk about, often using a model router.
A model router.
Yeah. Instead of hard coding, say, GPT-4 for every single thing, you use a much cheaper, much faster AI agent, that's your router, whose only job is to read the user's query or the workflow's need and decide where of those other more specialized models is the most appropriate and cost-effective.
Wait, so you use one AI to pick which AI to use. That's kind of meta.
It is, but it's incredibly efficient at scale. The router agent uses a simple system prompt with decision rules based on the query type. Is it complex reasoning? Is it asking for code? Is it general chat? Is it something simple? Is it multimodal? Then the real worker agent uses an expression in n8n to dynamically call the specific model the router recommended. You might even use a service like OpenRouter that connects to a whole bunch of different models.
Okay, whoa. So you actually get the best model for the specific job, and you keep costs way down because you're not using that Ferrari to deliver every single email. That really makes so much sense for a production system.
It's a hallmark of a robust production system, yeah. Finding that perfect balance of capability and cost.
All right, so picking the right brain or dynamically routing to the right brain is clearly key. What's next on the list of settings people often overlook?
Controlling creativity and reliability. This is where temperature and top P come in. And honestly, leaving these at their defaults is just like asking for unpredictable results.
Temperature. I've seen that slider in interfaces. What does it actually do?
Think of temperature as the creativity and risk dial, usually from 0.0 up to like 1.0 or more. A low temperature, like 0.1 to 0.3, means the AI is going to stick to the most common, safest, most probable word choices.
Okay.
It's super predictable, very factual, very consistent. That's what you want for, say, a support chatbot that needs to give the exact same correct answer every single time someone asks about your return policy.
Okay, so predictable and boring almost. Yeah. What if you want something more engaging, more creative?
Then you go medium, maybe, 0.6 to 0.9. The AI takes more risks, uses less common words, feels much more creative and human-like. That's perfect for marketing copy, generating social media posts, brainstorming ideas.
And high.
Yeah.
Like 1.0 and above. What happens then?
That's the danger zone. It becomes extremely unpredictable, often random, sometimes nonsensical, or, wildly hallucinatory.
Yikes.
It's almost never used in production unless you're, trying to brainstorm abstract art concepts with zero need for accuracy whatsoever.
Got it. So temperature is kind of like how adventurous the AI is with its word choices. What about top P? How does that work? Does it relate?
It does, yeah. Top P works with temperature. Think of it as the word choice filter or the size of the pool of words the AI considers for the next word. A low top P, say 0.3, means it only looks at the top 30% most likely words. Very safe, very conservative choices.
And a high top P, like 0.9.
A much wider range of words. Like 0.9 means it considers the top 90% most likely words. That allows for a lot more variety and creativity. A top P of 1.0 considers all possible words, which can lead to some pretty bizarre outputs.
So low temp and low top P is super conservative. High temp and high top P is pretty much chaos.
Pretty much. The source gives this really handy production settings formula table as a starting point for different use cases. For reliable business automation, they suggest temperature around zero point 0.2, top P maybe 0.7.
Okay, low temp, medium-ish, top P.
Yeah, and often adding a frequency penalty of 0.5 to 1.0 to prevent the AI from repeating itself. That's low creativity, high reliability,
Yeah.
low repetition.
And for like generating creative content, marketing stuff.
10.7, top P 1.0, frequency penalty maybe 0.5, high creativity, wide word choice, keep it fresh.
And like super structured output like JSON or code where format is critical.
You need extremely low creativity there to ensure it follows the format precisely.
Yeah.
Temp 0.1, top P lower 0.5, maybe frequency penalty 0.2. You're forcing it into a narrow, precise path.
Okay, so you have to dial these in for each specific task. You can't just leave them at default and hope it works.
Crucial. And the source also quickly mentions other critical model settings you find in that node. Max tokens, which prevents rambling and controls costs.
All right, stop it talking forever.
Timeout, for how long the workflow waits for a response.
Huh?
And max retries, which is important for production to handle transient API failures. Set that to like 2 or 3.
Good tip.
Sure.
Okay, so we've covered picking the brain and controlling its personality, I guess, with temperature and top P. What about memory? AI agents need to remember past turns in a conversation, right?
Yes, and this is another place where the amateur move can absolutely kill you in production, using the standard n8n simple memory or window buffer memory nodes.
Why? They seem easy to use when you're testing.
They are easy for simple tests or internal-only tools with maybe one user, but they use your server's RAM. In production, with, potentially dozens or hundreds of users all having separate conversations, that memory usage just grows and grows and grows. Eventually, it'll exhaust your server's RAM, slowing everything down, and ultimately crashing your entire n8n instance.
Oh, no, okay.
It's fundamentally not scalable for multi-user scenarios.
Okay, so that's like a hidden scaling killer. What's the professional alternative then?
Using a dedicated, external, scalable database for chat memory. The source specifically recommends PostgreSQL, and they point to Supabase as a really good option because it's easy to get started with and has a free tier.
Supabase, okay. I've heard of them. How does that setup work? Is it complicated?
According to the source, it's pretty straightforward. You create a free Supabase account, and then in your project settings, you get a connection string. They mention the transaction pillar connection string is important for managing connections efficiently.
Cooler, got it.
You just copy those details, host name, database name, user, password, into the n8n Postgres chat memory credentials setup.
So n8n talks directly to that database to store and retrieve the chat history.
Exactly. And crucially, in the n8n AI agent node itself, when you configure the memory, you must set a unique session ID for each user.
So conversations don't get mixed up.
Precisely. This is how the database knows which conversation history belongs to whom. You can use their username, email, or a unique ID from your system, and you give the table in the database a name, like NAT histories or whatever makes sense.
Okay, that makes total sense.
Yeah.
Separate histories, stored scalably in a database, not blowing up my server RAM. And you also configure the context window length here, right? How many past messages it remembers.
Yes, that's configured in the node as well. That controls how many of the most recent messages the agent remembers and sends back to the AI model with each turn in the conversation.
Right. How do you decide how long that should be?
For short, simple chats like basic customer support FAQs, maybe 5-10 messages is enough.
And for longer, more complex stuff, like planning or research.
Yeah, for conversations that build over time, like project planning or analytical tasks, you might need 20 or more messages for the AI to maintain good continuity and context.
So the rule of thumb is a larger window means better memory, but also higher cost and potentially slower response.
Precisely. Sending more text with every single request means a higher API cost and more processing time for the model. You absolutely have to tune this setting based on what your specific use case actually needs. Don't just crank it up to max.
Okay, memory problem solved with a database. Next up, tools. Giving agents the ability to use tools seems pretty fundamental. What's the configuration secret there?
The golden rule, as the source puts it, the more fields you leave blank for the AI to dynamically define when it calls a tool, the higher the chance of hallucination, malformed data, and the tool call failing.
Oof, that resonates. Can you give an example? Like, how does that play out?
Sure, they use the classic send email tool the wrong way. You leave the to email address, the subject, and the message body entirely up to the AI to figure out from the conversation.
Right. Just tell it, send an email about X to Bob.
And the AI might invent an email address for Bob that doesn't exist, forget the subject line entirely, or mix up the recipient and the content. Disaster.
Yeah, I've definitely seen variations of that happen, so the right way.
Predefine everything you possibly can in the tool node itself. Only let the AI control the specific parts where its creativity or understanding of the conversation is actually needed.
Oh, okay.
So for the email tool, you'd use an expression to pull the to email address from, say, a previous workflow step or a database lookup. You'd only let the AI define the subject and the message dynamically based on the user's request.
Okay, so you're essentially constraining the AI's creativity to only the parts of the tool call where its linguistic intelligence is valuable, not where it can just invent data and break the tool.
Exactly. It dramatically increases the reliability of your tool calls, and the source lists the available tool types in n8n, the hundreds of pre-built nodes for common services like Gmail, Slack, Airtable, Notion,
Some
databases.
usual suspects.
Yeah. Then the universal HTTP request node for interacting with literally any API, and even custom tools, which let you wrap another n8n workflow as a tool the AI can call, which is pretty powerful.
Pro tip is probably always start with pre-built.
Absolutely. They're the most robust and easiest to configure. Only resort to custom or HTTP if there's truly no pre-built node that does what you need.
All right, we've picked the right brain, we've controlled its randomness, we've given it scalable memory, and configured its tools smartly by predefining fields. What about the prompt itself? You said it's not just prompting, but it's still a key piece, right?
It is, but it's about writing a professional system prompt, not just, be a helpful assistant.
Like that vague stuff.
Yeah, that's like hiring someone and just saying, hey, be helpful, without any other direction. The source provides a really solid structured template, which is key.
Okay, walk me through that professional prompt template. What are the essential sections?
It breaks it down logically. First, you have the role persona. What is this AI, e.g.? You are a helpful customer service assistant for ACME Corp.
Clear identity.
Then the primary goal. What is its main task? e.g., your main task is to provide prompt, accurate, and friendly responses to customer inquiries based on the provided tools and knowledge.
Okay, clear job title and objective.
Right. Then, domain knowledge context. This is where you inject specific facts about your business, products, policies, etc. This is crucial so it doesn't have to guess or hallucinate information about your company.
Ah, okay, so it actually knows what it's talking about regarding my business. That's huge.
Exactly. Then, tools. Explicitly list the tools it has access to, when and why it should use them, and maybe a rule like prioritize using your tools over guessing if information might exist outside your core knowledge.
Tell it what tools it has and how to use them.
Yeah. And if you have a knowledge-based search tool, like for searching documentation, clearly lay out the rules for using it. Use this tool for all factual questions. Base your responses strictly on the search results. And if the search tool finds no relevant information, state clearly that you could not find the answer in your knowledge base. Don't let it guess after a failed search.
Okay, wow, so you're explicitly telling it what it knows, what it can do, and how it should use those capabilities. Very specific instructions.
Yes. Then, format rules. What format should the final output be in? Plain text, Markdown, JSON, maybe even a maximum word count.
Tell it how to structure the answer.
Style tone. How should it sound? e.g., maintain a friendly and concise tone. Use the user's name if available.
And safety and accuracy. That feels really important.
Super critical section. You explicitly state rules like, if you are uncertain about an answer, state your uncertainty rather than guessing. Never disclose internal tool names or proprietary internal information. Always adhere to company policies and legal requirements.
It's like giving the AI its full onboarding packet and employee handbook. All the guardrails.
Pretty much. Finally, an optional but often useful one, reasoning. You can instruct it to think step by step internally before providing your final response. This encourages a more deliberate process, though you don't necessarily show these internal steps to the user.
Okay, yeah, that makes so much more sense than just a couple of vague sentences. It moves from a vague command to a real structured professional delegation.
It just dramatically improves reliability because the AI understands its boundaries, its resources, and the expected behavior. Less guessing, more structure.
We've covered a lot of ground. Choosing the brain, controlling its output style, scalable memory, smart tools, professional prompts. What's next after the AI node itself? There's more.
Output parsers. This solves that incredibly common problem where the AI gives you the correct answer, but it puts it in the wrong format for the next step in your n8n workflow.
Oh, yeah. You need JSON. and it gives you a bulleted list. Or it messes up the JSON structure slightly.
Yeah.
So frustrating. Happens all the time.
Exactly. Output parsers are like the strict formatting guards right after the AI agent node in your workflow. The source lists three main types that are really useful.
Okay.
The structured output parser is for when you need a fixed JSON structure. You define the schema you expect, and this parser forces the AI's output into that exact shape, failing if it can't.
Okay, so that guarantees my JSON format, mostly. What about lists of things? Like if I ask for 5 ideas.
Item list output parser. This is for when the AI is supposed to return a variable list of items. You specify the separator character, maybe it's a between items or just a new line. And this parser takes that list-like text output and formats it into a clean, usable array in n8n.
Nice. Okay. And the third type, the one they call the professional safety net. What's that about?
That's the auto-fixing output parser. This is for mission-critical workflows where a formatting error is just unacceptable. If your primary AI gives you broken JSON or some other malformed output.
Which happens.
Right. This parser makes a second, usually very lightweight and cheap, AI call. It sends the broken output to the secondary model with a simple instruction like, please fix this broken JSON, and it returns the corrected, valid output.
Wow. So if the main brain messes up the format, a backup brain just swoops in and fixes just that specific formatting problem.
Exactly. It adds a tiny bit of cost and latency because it's a second API call, but it provides incredible resilience for systems that just cannot afford a formatting failure downstream.
That's smart.
The production strategy they suggest is often to use the structured parser for fixed formats, and for critical workflows, wrap that inside an auto-fixing parser node. Double protection.
That is genuinely smart. It's like a little formatting quality control step that happens automatically, built-in error correction.
Yeah, it's essential for ensuring the AI's output integrates seamlessly into the rest of your automated processes. Stops the whole workflow breaking because of one misplaced bracket.
All right, I think we've covered 6 of the 7. What's the last category of settings? Where else do we need to look?
The agent-level execution settings, right there within the n8n AI agent node itself. The big one here is max iteration.
Max iterations.
Right.
What does that control exactly?
This limits the number of back and forth steps the agent takes. You know, the cycle of the model thinking, deciding to use a tool, calling the tool returning a result, the model reading the result, thinking again, maybe calling another tool, and so on. Tool model.
Okay, the thinking loop.
Right. The default is often 10 iterations.
So if you have a pretty simple chat where it just needs to think and respond, 10 steps is probably fine.
Probably. But for a complex analysis task that might involve multiple tool calls or breaking down a problem, you might need to increase that to 15 or 20. An autonomous research agent using several tools could potentially go up to 30.
And the warning sign here, what's the danger?
Setting max iterations too high without other strong guardrails in your prompt or tool configuration can lead to the agent getting stuck in infinite loops, just calling tools over and over.
Oh, yeah.
And racking up incredibly high costs very, very fast. It's a critical safety limit. You got to be careful with that one.
Got it. Max iterations is a guardrail against infinite loops and uncontrolled spending. Anything else in that node we should know about?
Return intermediate steps. This is super useful during development and debugging.
How so?
It shows you the agent's entire thought process. Every time it thinks, every tool it considers, every tool it calls, the results it got back, how it decided its next step. It's invaluable for understanding why an agent did what it did and troubleshooting problems.
But you turn that off in production. For performance, maybe.
Yes, definitely. It makes the output much cleaner for the rest of your workflow once you've got the agent working reliably. You don't need all that internal monologue clogging up the final result.
Makes sense. And finally, automatically pass through binary images. That sounds specific.
Yeah, you just want to enable that. If you're building multimodal workflows that involve images, for example, if you're sending an image to, say, GPT-4 for analysis, it just ensures the image data is handled correctly by the node and passed to the model. Simple toggle, but important for vision tasks.
Okay, well, we covered all 7 areas. Choosing the right brain, or routing, controlling creativity and reliability, time.P, scalable memory with a database, configuring tools intelligently, predefining, writing professional structured prompts, using output parsers to guarantee format, and setting agent execution limits like max iterations. That is That is so much more than just writing a prompt and, hitting go.
It really is. And the source material really nails the impact this has on the results you get. It's night and day.
Yeah, let's talk about that. What's the real-world difference between building an agent the amateur way versus applying these principles? What does it actually look like?
Well, before applying these professional configurations, your agents work sometimes, right?
Yeah, sometimes. Maybe.
The outputs are unpredictable. They constantly break downstream workflows. Your costs are probably higher than they need to be because you're using the wrong models, and you spend hours manually debugging failures. It's honestly just an unreliable toy.
Yeah, that sounds painfully familiar to, I think, anyone who's tried this at any scale.
Yeah.
That debugging time is killer.
Exactly. After applying professional configuration, you get consistent, predictable behavior, structured outputs that integrate seamlessly into the rest of your automation, optimized costs because you're dynamically routing to the right model, and resilient self-correcting systems you can actually depend on. It transforms from a toy into a production asset.
So it's not just a little bit better quality output. It's about building something that's actually scalable, reliable, and can be the backbone for real business processes, something you can trust.
Precisely. It's moving beyond the demo phase and building automation that can, fundamentally change how you operate. It's serious business automation.
This deep dive really shifted how I think about building these. It's not magic or just hoping the AI is smart enough. It's architecture. It's engineering. It's deliberate configuration.
That's the core message the source wants to hammer home, I think. Stop treating NEs and AI agents like black boxes where you just throw a prompt in and hope. Start configuring them like the sophisticated, tunable tools they are.
Right.
The competitive advantage isn't having some secret model nobody else has. It's how you configure, how you constrain, and how you architect them. That's where the value is.
Yeah, it's like the slightly less glamorous stuff, the plumbing and the wiring,
Yeah.
that actually makes the cool, visible stuff work reliably, the behind-the-scenes tuning.
Totally. The companies and teams who are building truly reliable, innovative AI automation, they are absolutely using these kinds of professional configurations that, frankly, most online tutorials just never cover. This knowledge right here is the competitive advantage.
That's a powerful takeaway. Okay, so for you listening, maybe stop seeing your n8n AI agents as just, toys you're hoping will perform well. Start seeing them as systems you can design, control, and make dependable.
And maybe think about this. What specific part of your current workflow is maybe relying on an unpredictable AI toy right now? Where are you just crossing your fingers?
Yeah. I can think of a few places in my own setups.
How would applying even just one or two of these principles, maybe better model selection using a router, or dialing in temperature and top peak correctly, or implementing structured output parsers, transform it from an unreliable mess into a dependable production-grade system?
Yeah. And how would that fundamental shift, building that reliability, change what you can even attempt to build next? What new possibilities open up when you know it's going to work?
That's the provocative question, right? What becomes possible when the AI tool is truly reliable?